Hi students, today we are going to revise the chapter 2 polynomials, right? Polynomials, and while we are teaching this chapter, right? And this is a very important chapter, right? This is very important among the all 15 chapters, right? And this is very important, right? And this is the base for that algebraic equations or algebraic expressions, right? This is the base, right? Okay, before starting the chapter, right? We are having some definitions. First, thorough the definitions. First, thorough all the definitions, right? First, we will discuss the definitions of the polynomial, right? So first of all, write that standard form of a polynomial. Standard form of a polynomial is nothing but x power n, a x power n, a1 x power n, a2 x power n minus 1, a3 x power n minus 2, right? It's nothing but standard form of polynomial is nothing but writing the terms of the degree in decreasing order, right? Suppose the highest power is something but x power 6 means the first term should be x power 6, next x power 5, right? And next x power 4, and next x power 3, and next x square x, and next constant. Likewise we want to write, that is the standard form of a polynomial, writing the degree of the term in the decreasing order, right? Decreasing order. And next you want to know that what is meant by coefficients. Coefficient is nothing but, right, the coefficient of x. What is the coefficient of x? 2x. I'm just giving that. What is the coefficient of x? So before the x, what is the constant we are having? That is something but coefficient, right? Coefficient of x. Coefficient of x square minus 3 by 2 x square. That means now what is the coefficient of x square for this polynomial? Means minus 3 by 2 is the coefficient of x square. Suppose 2x cube minus x square plus 5x minus 7. So what is the coefficient of x square here? That means, see here, that nothing is there means, what is the mean? 1, right? So coefficient of x square is nothing but 1. So before that, what symbol is there? Minus. So minus 1 is the coefficient of x square. So coefficient is nothing but that what constant, right? What constant with the variable, that is something but coefficients, right? Next one is something but terms. This is very important, right? Terms, right? So terms is something but terms is splitted by plus and minus, right? Terms are splitted by plus and minus. Here 2x cube is one term, x square is one term, 5x is one term, minus 7 is one term, 7 is one term, right? So how many terms are there? 4 terms, right? Terms. So based on the terms, we are having some kinds of polynomials are there. Some kinds of polynomial, right? If we are having only one term, whatever it may be, if we are having only one term, then that is something but monomial, right? That is something but monomial. If we are having only one term, right? Only one term, that is something but monomial. If we are having two terms, right? We are having only two terms, then it is called as a binomial, right? That is called as a binomial. If we are having three terms, then it is called as a trinomial, right? And more than 3 terms is nothing but it is a polynomial. More than 3 terms is nothing but polynomial, right? If you are having only one term, that is monomial. Only 2 terms, right? Suppose 3x plus 5. How many terms are there? This is one term and this is one term. So 2 terms. So it's nothing but what is it? Binomial. 2 by 3 into x. 2 by 3 plus x. So how many terms are there? We are having only one term, right? 2 by 3x. So I'm just saying that I'm just giving one more example, right? 3x plus 5x. Now how many terms are there? One term, two term, right? We are having 2 terms. But this is monomial or binomial. That is very important. This is monomial or binomial. See that here 3x and 5x both are like terms. These 2 terms are like terms, right? If we like terms can simplify, right? We can simplify these 2 like terms and become as a one term, right? If it is not a like term, right? Both the terms are unlike terms, then we can say that this is it is a binomial, right? Here 3x plus 5x both are like terms. 3x plus 5x is equal to 8x. Now what is it? Monomial or binomial or trinomial? Monomial, right? So if both the terms are like terms, then we can simplify and then only we have to say that whether it is a monomial or binomial or trinomial, right? And next one is something but degree. Right? What is mean by degree? First of all, you want to know that what is mean by degree. It's something but the highest power of the polynomial. The highest power of the polynomial. See that I'm having this example, right? See what is the highest power? 1, 2, 3, 4, 5, 6. 6 is the highest power of this polynomial, right? So the degree of this polynomial is something but 6. right? Suppose I am having that here in this equation cube, right? X cube, x square, x constant, right? What is the highest power in this polynomial? 3. So the degree of this polynomial is nothing but 3. So degree is something but highest power of the polynomial, right? And based on the degree also, we are having some polynomials, right? The polynomial has been divided by based on the degree, right? Divided by based on the degree, right? So if the degree is 1, right? If the degree is 1, right? Then it's something but linear polynomial, right? If the degree is 1, right? Then that is something but linear polynomial. If degree is 2, right? If the degree is 2, then it is a quadratic polynomial. Then that is a quadratic polynomial. If degree is 3, then it is something but cubic polynomial. Then that is something but cubic polynomial. And if the degree is 4, right? Then it is something but biquadratic, right? Biquadratic polynomial, right? So here we don't want to count the number of terms, right? We don't want to count the number of terms. Only we want to see the degree, and by seeing the degree, we are going to give the name. What is the name of this polynomial? Whether linear or quadratic or cubic or biquadratic polynomial. Understood what I am saying? Suppose we are having only that x cube alone is there, right? Only one term, right? Only one polynomial, only one term. There is something but x cube, right? So what is a polynomial? What polynomial? This is something but based on degree. I am asking what polynomial? It's something but cubic polynomial, right? So what is the what is the degree of the polynomial? 3. So this is something but cubic polynomial, right? Based on the terms, what is the name of this polynomial? See that only one term, right? Based on the term, this is only one term. That is something but monomial, right? Monomial. So based on the term, its name is something but monomial. Based on the power, right? Based on the degree, it's something but cubic polynomial, right? Cubic polynomial. Understood? Next one is something but value of the polynomial. Value of the polynomials, right? Value of the polynomial is something but p of x. I'm just taking one polynomial. P of x is equal to x square plus 5x minus 7, right? I'm taking one polynomial x square plus 5x minus 7, right? I'm just substituting some value for x. X is equal to 2 or x is equal to minus 1. I am substituting some value for x, right? Instead of x, I am substituting some value and simplifying. Finally, I will get one value, right? And that value is nothing but value of the polynomial. Understood? Suppose I am just taking that x is equal to 2, right? So x is equal to wherever x is coming, we want to substitute 2, right? So 2 square plus 5 into 2 minus 7. 2 square is equal to 4. 4 plus 5 into 2, 10 minus 7. 10 plus 4, 7, 14. 14 minus 7, 7. So 7, the 7 is nothing but value of the polynomial. When we are substituting x is equal to 2, what value we are getting? 7 for this polynomial. So 7 is the value of the polynomial. 7 is the value of the polynomial, right? And next one is something but 0 of a polynomial. Next one is something but 0 of a polynomial. Right, some value we are substituting, right? Some value we are substituting, some value x is equal to, right? I'm just substituting and simplifying. Finally, I am getting the value, right? Value, that value is equal to 0, right? The value is equal to 0, then that x value is nothing but 0 of a polynomial. That x is nothing but 0 of a polynomial, because that x is nothing but making this polynomial as a 0. That's why 0 of a polynomial. Understood? What I am saying, 0 of a polynomial is something but you are substituting. See how many numbers, right? Whatever, right? How many numbers are satisfying it is equal to 0, that all the numbers are zeros of a polynomial. Zeros of a polynomial, right? So it is making that polynomial as 0, right? It is making the value of the polynomial as 0. So that which value is called as a 0 of a polynomial? That is called as a 0 of a polynomial. Understood? You want one more example? P of x is equal to 2x square plus 3x minus 5, right? I'm just taking that x is equal to 1, right? I'm just taking this x is equal to 1. So P of 1 is equal to 2 into 1 square plus 3 into 1 minus 5, right? Simplify. 2 into 1, 1 square 1, 2 into 1 2, plus 3 into 1 3, minus 5. 2 plus 3 5, minus 5 is equal to 0. So what is the value of the polynomial? 0. So which number is becoming the polynomial value of the polynomial is equal to 0? 1. Therefore the 1 is nothing but 0 of a polynomial. 0 of a polynomial. Understood? And moreover, you have to keep only one thing in your mind. This is very, very important note, right? This is very, very important note. That is something but the power of, right? The power of the polynomial, the exponents or the power of the each term of the polynomial should be a whole number. each term of a, right, each term, the power of each term, right, the power of each term of a, each term of the each term of the variable should be a whole number, right, should be a whole number. That means it should be a 0, 1, 2, 3, right. Suppose if it is coming -1 or minus negative values or decimal values, right, 0.1 or 0.2 likewise, or something like a fraction 1/2 or 2/3 likewise it is coming means, right, the power of, I'm just taking that, I'm just giving one example. 2x power -2 is there. This is a polynomial. No, it's not a polynomial because the power, right, the power is nothing but it is not in the form of a whole number. It is not in the form of a whole number, right? So it is not a polynomial. It is not a polynomial. Suppose I'm just giving that x power 1/2, right? X power 1/2. It is a polynomial. I told you that it should be in the form of whole number. But what is the power? Power is nothing but it is in the form of fraction. So it is not a polynomial. So, but we have 1/2 into x. 1/2 into x. This is a polynomial. Yeah, this is polynomial only because I told you that we want to check only the power of the variable, right? Power or degree of the variable alone, not degree. Degree means we will see only that the highest power alone we will see. But we have to see each term. We have to see the variable power of each variable, power of variable in each term, right? Each term variable power we want to see. Here power is nothing but nothing, one only. Nothing is there means one only. The 1/2 is nothing but coefficient, right? 1/2 is nothing but coefficient. So we can't say that this is not a polynomial, right? This is a polynomial. This is a by seeing the coefficient we can't say that this is nothing but what is that? Polynomial or not a polynomial. Only by seeing the power, right? Only by seeing the power, right? Right? And first you can just complete all the exercises in your class works, right? And in the exercise 2.1 is nothing but completely based on the right definitions, completely based on the definitions, right? And exercise 2.2 is nothing but value of the polynomial and 0 of the polynomial, right? The sums based on value of the polynomial. Find the value of the polynomial or find the 0 of the polynomial, right? Find the value of the polynomial and find the 0 of the polynomial, right? And exercise 2.3 is nothing but based on remainder theorem, right? Remainder theorem, already we know that remainder theorem, right? When we are dividing by one polynomial by another polynomial, right, that second dividend is equal to, first we want to know that dividend is equal to divisor into quotient plus remainder, right? So divisor, so when we are dividing one polynomial by this divisor, right, so finding the remainder is nothing but we want to equate divisor with 0. We want to equate divisor with 0, right? Suppose p of x is equal to some polynomial and g of x is equal to some polynomial, right? And we want to equate g of x is equal to 0, right? G of x is equal to, suppose x plus 5 is there means x plus 5 is equal to 0. We want to find the value of x by equating with 0. Then x is equal to what is that? -5, right? Substitute x is equal to -5 by using by which method? Value of the polynomial method, right? Finding the value. Substitute x is equal to -5 in p of x, right? Finally we will get one value. That value is nothing but a remainder. When dividing by p of x, when dividing p of x by g of x, we will get some remainder. That remainder is nothing but by simplifying p of x, right? By simplifying p of x, right? Next one is nothing but, right, remainder theorem. Next factor theorem, right? Factor theorem. We want to check whether the given number is a factor of this polynomial or not, right? Given polynomial is a factor of a polynomial or not, right? G of x. So the same thing we have to equate with 0, right? We will get the value of x. Substitute x in p of x, right? The final value p of x is equal to, right, the final value, it is equal to 0, right? It is equal to 0. Then the g of x is nothing but factor of p of x. Understood? G of x is nothing but factor of p of x. See that they ask you to check whether g of x is a factor of p of x, right? So we want to equate g of x with 0 for getting x value. X is, we are getting, after getting x value, right? Substitute x is equal to some value in p of x, right? And simplify. Finally you want to get 0. If it is equal to 0, then it is a factor of the p of x. Otherwise it is not a factor of p of x, right? And the last exercise is nothing but identity, algebraic identities, right? The last concept is nothing but algebraic identities. First thorough the algebraic identities, right? We are having a different kinds of identities, right? One is nothing but two kinds of algebraic identity. That is nothing but square based and cube based, right? Square based and cube. Square based, how many identities we are having? Totally 10 identities, right? Among the 10, 5 is nothing but square based identities, and the remaining 5 is nothing but cube based identity. Right? In the square also, it has been divided by the variables, right? 2 variables and 3 variables, right? A plus b the whole square, a minus b the whole square, a square minus b square. The first 3 identities are based on 2 variables, right? And the fourth and fifth identity is nothing but x, a, b, 3 variable, and a, b, c, 3 variables, right? X plus a into x plus b is equal to x square plus a plus b into x plus ab. That is fourth identity. And fifth identity is nothing but a plus b plus c the whole square, right? So first thorough the identity, right? And see the question and see that which identity will be suitable, right? For which identity will be suitable, just write the formula and substitute and simplify. We will get the answers, right? We will get the answers. And factorize, right? Usually how we will do the factorize? By doing that factorization, multiply value, addition value, that methodology. Factorization by identity means, right? Factorization by identity means, right? In exercise 2.5, right? We have done so many sums, right? So by applying the identities, we will factorize. So solve the sums, right? And first complete all the sums in your classworks, right? First complete, right? First complete all the practice all the sums in your classwork, and then you just go to that worksheets and extra sums, right? Thank you.